Electricity is the invisible force that powers our modern world. It courses through our homes, animates our cities, and fuels our ambitions. It flows from the simple light above your desk to the colossal reactors that may one day power entire planets. For over a century, we've mastered the art of generating and distributing this power. But what happens when a new kind of intelligence, an artificial one, becomes the new spark behind the entire electrical industry? Today, we'll explore how artificial intelligence is fundamentally revolutionizing the flow of power, from the smallest local businesses to the grandest scientific endeavors like fusion reactors. We'll examine the quiet changes happening right now and the monumental shifts on the horizon. And we'll ask the ultimate question: is AI not just a tool for managing energy, but the future of energy itself? To understand AI's impact, we first have to appreciate the complexity of the system it's entering. The electrical industry is far more than just wires and transformers. It's the intricate, sprawling nervous system of modern civilization. And if that's the case, AI is rapidly becoming its new, supercharged brain. AI is already deeply embedded in the grid, performing tasks that were once the domain of human intuition and slow calculation. Sophisticated algorithms now predict energy demand with astonishing accuracy, analyzing weather patterns, social events, and historical data to anticipate needs down to the neighborhood level. This foresight allows utilities to generate just enough power, reducing costly waste and environmental impact. Smart grids, powered by these algorithms, can instantly reroute power during outages, isolating faults and minimizing disruption before most people even notice a flicker. This is especially critical for the green energy transition. The sun doesn't always shine and the wind doesn't always blow. Machine learning models are the key to solving this intermittency problem. They forecast renewable energy output with incredible precision, seamlessly balancing the fluctuating supply from wind, solar, and hydro with demand, and deciding in milliseconds when to store excess energy in batteries or release it back into the grid. What once required entire teams of engineers making manual adjustments can now be handled autonomously by AI systems that learn, adapt, and optimize on the fly 24 hours a day. But this technological revolution isn't just for billion-dollar utility companies and sprawling national grids. It's a powerful democratizing force, transforming small electrical businesses too. For the independent contractor or the local family-owned shop, AI is becoming an indispensable partner. Picture a local electrical contractor arriving at a new construction site. Instead of spending hours manually drafting plans, they use an AI-powered tool on a tablet. It analyzes the building's layout, suggests the most efficient wiring paths, generates compliant blueprints, and even creates a detailed bill of materials. The AI can cross-reference local electrical codes to ensure compliance and even simulate load requirements to prevent future issues for the client, adding a layer of professionalism and foresight that was once out of reach. The back-office operations are also being revolutionized. Smart assistants can handle appointment scheduling, send automated reminders to clients, and even field basic customer service inquiries, freeing the business owner from administrative burdens to focus on strategic growth. AI-driven supply chain systems can scan inventory levels in the workshop, track the materials in every van, and prevent shortages by automatically reordering parts. More than that, these systems can scour the internet for the best prices from different suppliers in real time. For a small business, these aren't just convenient luxuries. They are game-changing lifelines that boost efficiency, cut costs, and turn a one-person shop into a highly competitive, data-driven operation. Now let's scale back up to the utility level, where AI is fundamentally redefining the very concepts of power generation and distribution. In the control rooms of modern grid operators, AI is the ever-vigilant co-pilot. It constantly analyzes millions of data points to predict energy surges from a factory coming online, or sudden dips from a neighborhood-wide event. It doesn't just flag these anomalies, it automatically compensates by shifting loads to different circuits, activating reserve power plants, or even communicating with smart appliances in homes to slightly delay their energy consumption, all within seconds. In the world of renewable energy, AI's role is even more direct. It acts as a digital botanist for solar farms, predicting cloud cover and sunlight intensity to precisely angle solar arrays for maximum absorption throughout the day. For wind farms, it's an expert meteorologist, adjusting the pitch of each individual turbine blade based on wind strength and direction to maximize output and minimize mechanical stress. This intelligence becomes most critical during extreme weather events. When a hurricane, wildfire, or crippling heatwave threatens the grid, AI is the first line of defense. It can predict which lines are most vulnerable and proactively de-energize them. It helps prevent catastrophic blackouts by intelligently isolating damaged grid sections, creating microgrids that can function independently and stopping failures from cascading across the entire system. This resilience is no longer just a goal, it's an AI-driven reality. Beyond real-time operations, AI-driven predictive maintenance is one of the industry's most profound and quiet revolutions. The old model was, wait until it breaks. The new model is, fix it before it even knows it's broken. Thousands of sensors deployed across the network, on transformers, substations and transmission towers, feed a constant stream of data to AI platforms. These systems are trained to recognize the digital signature of failure, detecting almost imperceptible signs of trouble like overheating transformers, weakening connectors, or minute voltage irregularities long before they escalate into a full-blown outage. This proactive approach also transforms worker safety. Instead of sending crews to perform dangerous, manual inspections of high-voltage equipment, utilities now deploy fleets of robotic drones. Equipped with high-resolution cameras, thermal imaging, and LiDAR, these drones, guided by AI vision systems, can inspect hundreds of miles of power lines automatically. They can spot frayed cables, vegetation encroachment, or structural damage that would be completely invisible to the human eye from the ground. The result is a paradigm shift, fewer unexpected outages for consumers, a dramatic reduction in risk for electrical workers, and a far more reliable and cost-effective energy supply for everyone. Maintenance becomes surgical and precise, not reactive and chaotic. Now, let's go big, really big. To the holy grail of clean energy, nuclear fusion. Fusion promises almost limitless carbon-free power by replicating the process that powers the sun. But containing a star in a box is arguably one of the hardest engineering challenges in human history. Inside a fusion reactor, or tokamak, hydrogen plasma must be heated to over 150 million degrees Celsius, 10 times hotter than the core of the sun, and confined by immensely powerful magnetic fields. The problem is, this plasma is violently unstable. It wants to escape. For decades, controlling it has been a monumental struggle. That's where AI comes in. AI systems, specifically a type called reinforcement learning, can monitor thousands of sensors and make microsecond adjustments to the magnetic fields to stabilize the plasma flow, something no human team could ever do. In a major breakthrough in 2023, researchers at Google DeepMind and Swiss Plasma Center used AI to successfully control the plasma's shape and position inside experimental reactors, a task that once took years of painstaking human trial and error. This is not a minor improvement, it's a fundamental enabler. The next generation of fusion designs, from private companies like Tokamak Energy and Commonwealth Fusion Systems to the massive international ITER program, now rely heavily on machine learning. AI simulates and optimizes the brutal conditions inside a reactor before a single dollar is spent on construction, dramatically accelerating the path to viable fusion energy. So when we zoom out, the picture becomes clear. From a neighborhood electrician's digital toolkit, to the continental smart grid, to the fiery heart of a fusion reactor, AI is becoming the ultimate electrical apprentice. It's an apprentice that never sleeps, never forgets a single data point, and never stops learning from its mistakes. It is a force multiplier for human ingenuity. It's making our energy supply smarter, cleaner, safer, and more resilient than ever before. But this rapid integration also raises a crucial philosophical question about control. As we hand over the reins of our most critical infrastructure to these complex algorithms, who truly controls the intelligence that controls our power? Will we succeed in designing systems that are transparent, accountable, and always serve humanity's best interests? Or will we become so dependent on them that we can no longer function or even understand our own world without them? So here's my question to you, and I genuinely want to know what you think. As AI becomes capable of running our electrical grids and even our future fusion reactors with superhuman speed and precision, should humans always have the final say, a kill switch, even if it means risking a blackout? Or should we trust the AI to make its own real-time decisions to keep the lights on, even if that means overriding a human operator's command? Where do we draw the line between intelligent automation and ultimate authority? Let me know what you think in the comments below. I read every single one. If you enjoyed this deep dive into how AI is transforming the electrical industry and what it means for our future, do me a favor and hit that like button. Share it with a friend who loves technology or is curious about the future of energy. And of course, subscribe and turn on notifications for more videos where we explore how AI is powering the world and shaping our destiny. Because the next great revolution in energy might not come from a new type of fuel or a new invention, but from a new kind of intelligence.